LIATE rule, which is a pretty cool idea, I learned in the United States from one book. And surprisingly, they don't teach it in other classes in other books, which is a very sad situation because LIATE saved me so much time. The formula for integration by parts is integral u dv equals uv minus integral v du. Some students memorize it. Most students actually just memorize the pattern. I will show you. When you choose what to have as your u, this is a very good hint, which works almost all the time. Choose first, so whatever comes first in order, like so. If you see log, definitely choose logarithmic function. That is, for example, ln x plus 5. Yeah, choose that to be u. If you see inverse functions, what are inverse functions? Arcsines, or sine minus 1x, arctangent, right? Arctangent x squared. Choose that to be u if you see that, but not log. There's no log. There's no log, there's no inverse. Then choose something, whatever is going after this, which is algebraic functions, which are something like x squared plus 5, whatever. If none of this is present, but there's a trigonometric function, then choose that. It is sines, cosines, tangents, secant. And the last choice should be exponential function. These actually are usually troublemakers. This is the worst situation. And that's going to be your last choice. Remember, integration by parts undoes product rule. Undoes product rule. So we just learned how to undo chain rule with u substitution. Now we are learning how to do product rule, which is the most popular situation in science. Usually there are two functions multiplied and they mean different things. And that's the model of the plane going to heading out to another country, the shuttle going to the space, the bacteria mutating. All of those usually are products. So we want to integrate. That means we're going to use integration by parts most of the time. Example. So we did this formula last time, and let's have a nice example. Let me see. Oh, we did have example last time. I just realized that. Here it is. We finished example last time. We chose this u, and I never explained how the choice was made. To be honest, LIATE is not a theorem, it's just a pattern which tells you that what is more convenient to choose. LIATE says, choose whatever you see first. There was no logs in this first example. The example had x and sine x. Then there were no inverse function, but it was algebraic and trig, x and sine x. So whatever comes first in the order of LIATE, that is a good choice for you. And that's why we chose u to be x. Let's work on more examples so it's better for you to understand. The more you do, the better it gets. Example 2. Which is, let's try definite integrals. Let me actually write it down. Definite integrals. Bless you. Integral from 1 to 8 ln x over x to the 7 dx. Very interesting. We did integral like this before and we used u substitution, but it was a little bit different. It was ln x over x. Ln x has connection with 1 over x, and that's why we used u substitution. Because if you choose ln x to be u, du is 1 over x, dx. But this guy is a bit different. It's from 1 to 8, ln x, and then it is x to the minus 7. And because now it is not 1 over x, it's 1 over x to the 7, it messes everything up. So u substitution works when one piece looks like derivative of another piece. Here, it's a product of two different functions, and that's why it gives you a hint to use integration by parts. Usually people put here IBP, so when you review your notes, you don't get surprised what the heck just happened. It's nice to have notation of the method you chose. Now, we're starting the table. We need to choose something to be u. What comes first in the list of LIATE? Log. And it's not first in the integral. Don't make it confused. It's in this list. Exactly. If you see log, choose that to be u. So we have log and algebraic function x to the minus 7. Log is the first one in LIATE. Let u be log x. Then du is 1 over x dx. That is the left side of the integration by part. The right side is, if this part is u, everything else does not have a choice, it's du. dv. Everything else, let me put a different color. Oh, that's too fat. Everything else does not have a choice, it's dv. So that's a different part of what we were used to be doing with u substitution. dv is x to the minus 7 dx. v is, so there used to be u, we found du, that's differentiation. Now we have dv. To find v, we integrate. Integral of x to the minus 7 is what? Minus, okay, let's see. X to what? Minus 6 divided by minus 6. Should be plus c, and this time I will explain you why we don't put plus c. Right now, it actually will make sense. Equal sign. Visually, it is cross product minus bottom product. U times V, that's the formula I just showed you. Here it is. U times V minus integral V du. But I remember it visually. Cross product, and this part is already integrated. ln x times x to the minus 6 over minus 6. Next is the negative sign. It's part of the formula. Here it is. Negative sign. So it's always minus after this. Minus. And then integral. And multiply the bottom, which is x to the minus 6 over minus 6 times du is 1x dx. 1x dx. So one thing I just mentioned, why we don't need plus c. When we have this plus c, it will be here and then here with a negative sign because of the negative sign in the formula. So c cancels out. That's why we don't need it. And the other explanation is, at the very end of indefinite integral, there will be another constant anyways. So this fat, huge plus c accumulates all the constants at the very end. That's why in the box they don't put it usually. It takes too much space and doesn't make sense. There's one thing is wrong here. Who noticed? Limits of what? 1 and 8. That's what you want to say to? Yeah. 1 and 8. Limits of integration, where did they go? Here they are. Bar 1 to 8, integral from 1 to 8. Like so. If it's a definite integral, unlike in previous example, you actually have to plug numbers. Again, if you get the function as the answer for definite integral, you're wrong. Because the answer for a definite integral should be what? A number. Should be 27 over 3 or whatever, minus 17, 0, but it should be a number, pi, million. So look at that, how interesting it is. The first piece is completed in terms of integration. I just need to plug the top minus the bottom, 8 minus n 1. And the second piece is waiting for you to integrate. So it's very interesting. That's the whole idea of integration by parts. It breaks integral into parts. That's where the title comes from. This one is ready. You maybe just need to plug numbers. And this one is hopefully easier integral than before. Breaking into parts. That is the idea. So, very interesting. Do you want to plug top minus the bottom now, or you want to integrate the second part first and then plug 8 and 1 everywhere? Both are correct. My point is, I can start plugging this now and then integrate this, or I can wait not to plug it, integrate the second integral, and then plug it everywhere. Depends how you like it. Doesn't really matter. I will do one or the other. I will plug 8 first. ln 8 to the minus 6 over minus 6 minus plugging 1. ln 1, which is what? 0. So the whole thing is 0 anyways. 1 over minus 6. This is plugging the, I'll put it in the pink color. This is plugging top minus the bottom, first integral, first result of the first integral. Minus, that minus is part of the integration by parts formula. And now I'm integrating the second integral, which looks worse than we had before, but is it? It's not. Sounds like no. Let's simplify. Take a pencil or another color and simplify. Don't write down the whole thing again. Too much writing. I teach people how to use pencils a lot. Take a pencil or another color, red color or something, and write it down that this is actually integral from 1 to 8. And now simplify. X to the minus 6 times x to the minus 7, right? Do you see? It's just x to the minus 7. X to the minus 6 times x to the minus 1 is what? X minus 7, I just spoiled it myself, over minus 6 dx. This is how the whole integral looks like when you simplify it. Just be careful with powers. Now you can integrate it. So x to the minus 7 becomes what? X to the minus 6 again over minus 6, and there was a previous minus 6. So it's 36. Bar from 1 to 8. And you see, I'm again have to plug 8 and 1. So some people like doing it at the very end for everything at once. Let's simplify the first piece in pink. The first part is just some kind of number. ln of 8, 1 over minus 6, in parentheses, put parentheses, times 8 to the 6, which is some number you can calculate. But ln 1 makes everything 0, because ln 1 is 0. So I can ignore the second part. Minus, and now plug the top and the bottom for the second part. 8 to the minus 6 over 36 minus 1 to the minus 6 over 36. This is the final answer. If you are lazy to simplify, I am. So that is what I would type in the program or leave for a professor to grade. Let's see if I actually have approximation. I do have the final answer. It's approximately, if you're curious. So for mathematicians do not like approximate answers. That's why I used to never give approximate answers. And then I learned that there are other majors outside of math. So engineers, physics major, chemistry majors, you actually have to give some kind of intuitive answer for public or your own research group what this number is. Is this a million? Is this negative? Is this pi? Is this half? 23 gallons or 5 gallons or a million gallons. So apparently it's 0.0278 wherever units, right? So in other majors, it's actually pretty important to have some kind of intuitive answer. I always recommend you to type in and use exact answer, and I'll tell you why in a second. But approximate answer also is important when you're building something. Sometimes you need to be approximate at the moment. What do you think about this? Questions, ideas, suggestions? Ask me 2 questions. So I will write down the next integral and tell you why approximate answer kill people sometimes. If you're working in microbiology, just a second. Well, now I already started my story. Let me finish the story. Sorry. If you work in microbiology, you may know that computers now do performing appendicite surgeries and other surgeries. So the person behind a robot, controlling the robot, and the robot's now cutting people. So you know, if it's like 0.0278 and you answer 0.03, that might be like someone's liver over there. So actually it's important. Approximation has an error, which we all know. And the size of the error matters on the discipline. In microbiology, 0.0005 might be not good enough. In macrobiology, which is space science, NASA, working with space objects, many of you actually are space engineers, right? There, 0.03 might be a pretty good error because you shoot into space, it flew by like 25 kilometers far away, still good enough. So it depends on the major, it depends on the project you're working on. So it's because I was working in microbiology, I know that the error matters. Yes, there was a question. Yeah. On a test, I usually tell you, give me approximate and exact answer. And then either or usually is correct. Sometimes I actually try to ignore a wrong one and choose the correct one to give points. So that's why it's also good. Any more questions? People were too afraid to interrupt me? No? Yes?
Could you please explain second integration again? I did not understand how we got x minus 6 upon.
Thank you. I was wondering if someone asks. That's a good question. So what I did was, this integral can be written as integral from 1 to 8, x to the minus 6 over minus 6 times x to the minus 1 dx. So that's what I changed. 1 over x is x to the minus 1. Bless you. Then I collected terms from 1 to 8. X to the minus 6 and x to the minus 1 adds up to be x to the minus 7. And minus 6 just there waiting for you, right? And then the integral of x to the minus 7 becomes x to the minus 7 plus 1. That is x to the minus 6 divided by minus 6. And the other minus 6 was there waiting for us. Does that make sense?
Which minus 6 is waiting for us?
This one, yeah. This one was there, so I just keep putting it there. And the new one showed up. The new one showed up because of integrating this function. X to the minus 7 is x to the minus 6 over minus 6. But there was a previous minus 6 from previous integration. So it's keep kind of waiting to finish integration. See, very good. Actually, people are checking all the details. That's exactly what I hope you guys do. Thank you. Finally, we can integrate logarithmic function. We never did it before. We just learned how to integrate tangent last week. So it took U substitution to learn how to integrate tangent. Well, logarithmic function has its own Wikipedia page for a reason. It's one of the most important things, discoveries. Logarithmic function. One of the most important discoveries in mathematics and STEM is logarithmic function. You'll be surprised. But it has a Wikipedia page. And one of it, so how it was discovered, and and the properties which you saw before, but one of it is actually integrating it. And to integrate it, it says you're required to know integration by parts. Derivatives, we just learned derivatives in calculus 1, integrating. So, let's do it. Integration of logarithmic function requires integration by parts. But I just mentioned that integration by parts needs to have product of two things. We are undoing product rule. So where is the product? I didn't see a product. It's log x. Yes? Both. Just say at the same time.
I think we're both going to say multiply by 1.
Yes. Multiply by 1. Thank you. If you multiply by 1, then you can see that those are two functions. One is actually function y equals ln x. And one is constant 1. I can see sleepy people in the classroom, like, those morning people are so active. I hate them. No negative vibes in the class. But I used to be like this. I'm also a morning person, so I would show up and everyone would be sleeping. Nobody liked me because of that. So, then let's choose something to be u. LIATE has a very good guess. Again, I was learning integration by parts myself without LIATE. It was pure guess every time. I'm guessing one of two functions, and it's wrong. And I spent so much time, I don't know, choosing this to be u, or 1 over x to the 7 to be u. It doesn't work. You spend the whole page writing, and it doesn't work, and then something works. Then in the United States, they taught me this LIATE thing, and I was just happy but upset at the same time, because I wasted lots of time on this. If you see log, guess what? Just use that to be u. So convenient. It's like the best helper ever. I see log an algebraic function, which is 1. And that's why I'm choosing u to be log, because of LIATE. Let's put integration by parts, just to make sure we know this. u is ln x, du is what? 1 over x dx. Good job. Then what is dv? Who knows? 1 dx. dv doesn't have a choice. Whatever is left, that's dv. So we need to integrate 1 dx. What is v? X. Good job. X plus c, we don't write c for integration by parts. Okay, either you remember the formula uv minus integral v du, or you remember cross minus integral of the bottom product. Cross ln x times x minus integral x times 1 over x dx. While you're writing, I'll keep talking. The idea of integration by parts is to break complicated integral into a piece which is integrated, and then another piece which is hopefully an easier integral. That is the idea. Ask me, was it too fast how I did it? U times v minus v times du inside of the integral. That's how we do it. I saw that some people organize this table differently. I don't mind. Again, organization of the information is up to you. You can flip those sides. You can do a whole line of things here. Doesn't matter to me. This is just the method you're using. How you're using, that's on you. But this should be correct after this equal sign. So see how careful I am with notation? The box is floating somewhere on the side or in the air. Equal sign has only there between two equal things. Integral, and then the result of the formula of integration by parts. So unless this is correct, I don't mind how you did it. That is good. The first part is done. Let's call it x ln x, because it looks better this way. Minus, what is integral of x times 1 over x? Wait. Okay, I see different answers. What is x times 1 over x? 1. Why we can cancel? What if it's 0? You cannot cancel zeros. But because we're working with logarithmic function, x is restricted to be positive. If x is positive, it's just a positive number. 5 and 1/5, 7 and 1/7. So you can cancel it out. But you cannot cancel something which might be 0. But again, 1 over x cannot have x equals 0. So it's also fine. So this is integral of 1 dx. X ln x minus x. And since it's, thank you, since it is indefinite integral, plus c pops out at the very end. This plus c over here cancels out because of the formula. But the very last integral gives you one more plus c, and it's this what I call big fat plus c that accumulated all the previous c's anyways. So, let me show you here. This is exactly the formula, what they give. Some people memorize it. Integral of log is x ln minus x plus c, but most people just know how to get it. It should be done via integration by parts. Now you know. So derivative, this is actually implicit differentiation, integral, and then integral of 1 over x gives you log. What do you think about that? I think it's pretty cool too. Well, thank you. Someone said pretty cool. I think so too. Isn't it interesting that such a simple function took us calculus 1 and calculus 2, beginning of calculus 2, to actually integrate? Because logarithmic function is phenomenal. It actually has so many applications, and I will show you those applications in the future as well. It's actually pretty cool. So, one more thing I wanted to mention. Check this out. Here, we have indefinite integral. The answer is a function. We know that. We perform integration by parts. But when the integral was definite, then what? With a definite integral, we never changed limits of integration. 1 and 8 stayed as 1 and 8, as you can see. So here's my equal sign. It went over here. And 1, 8 did not change anything. Why? Because unlike in the previous times, U substitution was a transformation when I was pouring water from any random object into the measuring cup, I performed a transformation, and that's what U substitution is. We're taking water or area below the graph and transforming it into a different integral. So we have to change limits of integration. Integration by parts is not a transformation. It's just calling names. We just call this part to be U, and the other part becomes automatically dv. That's it. So we actually never changed limits of integration. We kept them as it is, and it worked fine. 1 and 8 stayed everywhere, 1 and 8. So let's make a note. Let's make a note about this. Note. Unlike in U sub, which you're going to be doing right now in the quiz, unlike in U sub, you do not change limits of integration when you perform, I will just do for integration by parts. Because integration by parts is not a transformation, it's just a formula. We just call names and using a formula. Let me know if you don't like my handwriting, I can fix some stuff. Unlike in U substitution, you did not change limits of integration for integration by parts method. It's not a transformation. So technically speaking, all students every time tell me that 6.1 chapter is easier than 5.5. You just follow the formula and it's good enough. So that's why this number of examples actually is good enough to do all the homework, except the recursive integral is a pain in the butt, because I will show you right now why, but that is why I made a very good YouTube video about this. So in recursive integrals take 20 minutes to explain, but it's pretty cool. You will watch in the video how some functions like sine and cosine keep exchanging with each other. Derivative of sine is cosine, derivative of cosine is sine, plus or minus. So when you perform integration by parts, you end up to be with the same integral you started with. It never happened before. And that's why that idea has different method of solving for the integral. Because no matter how long you do integration by parts, it's keep bringing the original integral. So that's a recursion. Computer science people know what recursion is. So it's keep being repetitive. And I have a whole video on this, which is pretty cool, and you should check it out, because it's annoying but interesting idea. Let's do one with trigonometric functions. Example 3. Integral of 3 pi over 2 pi, your favorite trigonometric functions. Next week we will be working with lots of trigonometric functions. So that is quite important. And then x cosine x dx. Soon I will be asking you which method are we using, because we will learn like 5 methods after next week. Next week we're going to cover 2 or 3 more methods. So the total will be 5 or so. Now we know 2. Use substitution integration by parts. Which one to use for this example? No, which method? Sorry. Integration by parts or use substitution? Integration by parts. That is the correct answer. But why? Don't tell me because it's a chapter about integration by parts. That's not the reason. Why? Yeah? Exactly, it's a product of 2 not relatable functions. If you have log and 1 over x, probably u sub. If you have sine and cosine, probably u sub. If you have x cubed and x squared, probably u sub. Because derivative of one looks like derivative of another one. Cosine and x have no connection in terms of differentiation and integration unless you go to complex analysis. They actually are connected there. So, equal sign. We choose to have integration by parts, very good choice. U should be what? Okay, LIATE. Which one did you choose? Cosine. Let's check if you're correct, but I think you are. LIATE. So usually I write LIATE like so, and then I quickly remind in my mind, log, I don't see log. Inverse functions, arcsine, arccosine, arctangent, I don't see those. Algebra, that's x. Trigonometric, that's cosine. E, that's exponential. Which comes first? Algebraic. See, we're very close. Algebraic comes first, so x is a good choice for u. But again, when I did not have this tool, I would choose randomly and then it will not work. And then I would get frustrated. And then you have to choose another one and it works. Unless you do a mistake, then the second one doesn't work. And then you're lost. And then you just go and play video games. Like this, right? Am I right? This is life of STEM people. You need to have some kind of enjoying outside hobby to survive. 1 dx comes from du. Now the other part, if this is u, the other part is dv. That doesn't have a choice. That's just a leftover. The leftover is called dv. Again, we're calling names. It's just calling it dv. V will be integral of cosine, which is sine or negative sign? Plus sign, because when you differentiate, sine gives you cosine. Sine x, and this is your box. Integration by parts, boxy box. And now I just remember visually cross product and bottom product. Or maybe once I should actually mention u times v minus integral v du. That's exactly what the formula is. U times v minus integral v du. Either remember the formula or the visual effect of this box. So x times sine x, that's u times v. U times v, cross product, x times sine x. Someone should tell me the other part. I should stop actually doing it for you. Someone, the end people, are you sleeping or not too bad?
Sin x dx.
Okay, how about you?
Those should be minus the integral of sin x.
Minus integral sine x dx. Correct, both correct. But more details are better. Minus integral, minus because it's part of the formula. Sine is v, and then 1 dx, that's du, which is just dx. Again, did we do it correctly? Let me finish my sentence. Yes, well, I hope so. Maybe hence means I did a mistake. Because we broke a complicated integral into simple piece and then hopefully an easier integral. Yes?
Well, since it's a definite integral at the top, and it's at the bar, I got your sin x.
Good job. So you caught this idea that actually it had limits of integration. So usually I write down like this to check the formula and then I add limits of integration. Or maybe I just forgot. You will never know. I guess we'll never know. A bar 3 pi over 2 pi and the integral 3 pi over 2 over n pi. We broke the complicated integral, which was product. It was the result of the product rule, x and cosine x, two not relatable functions, into a simple piece and the hopefully easier integral. And now it's up to you. You can wait to integrate second integral and plug pi and 3 pi over 2 everywhere. Or you can start plugging right away for the first piece. Let's wait this time to have two different cases. Why not? X sine x, a bar 3 pi over 2 n pi. I will wait for the next integral to be completed or integrated. Minus, what is integral of sine? Negative cosine. So let me put plus. And then at home, you will have to figure out why it became plus. Integral, no. Cosine x. You can do it. Come on. Yes, it's not handling the recording program. Go away. Cosine x. Oh, now it's working. A bar 3 pi over 2 pi equals. And now check it out. You can actually plug everything at once first. So you can plug top everywhere. X, so instead of x, we're plugging pi. Pi, sine pi. I was so close to finish this video. Sine pi, which is 0, by the way, plus cosine pi. And that's plugging the top everywhere. Some students like doing it this way. And then minus, and you start writing down what happens when you plug 3 pi over 2. So this one is plugging x equals pi everywhere. Minus, and now we're plugging the bottom everywhere. which is 3 pi over 2 sine 3 pi over 2 plus cosine 3 pi over 2. Who remembers what is sine and cosine of 3 pi over 2? We will be doing lots of trigonometric functions, so reviewing the circle for angles will be pretty important in this class. Is there any mistake? This one is plugging x equals 3 pi over 2. Anyway, sine of pi gives you 0. Cosine of pi gives you what? Negative 1. So 0 minus 1. What is the other stuff? What is sine of 3 pi over 2? Negative 1. Nice. Some people remember. That's good. And what is cosine? 0. What is it? 0. So this piece gives you 0. And then if you simplify, oh, it did. It becomes 3 pi over 2 minus 1. 3 pi over 2 minus 1.